Alrighty, first lesson of chapter 10 is all about rational exponents. So rational meaning it can be written as a ratio. So we're dealing with exponents that are fractions. So you can see the definition here just using variables. So it says the definition of b to the p over q is the same as saying the qth root of b raised to the p power. So it's a little easier to see that when you look at examples. So if you look at b to the 1/2 power, the denominator of that fraction, so 2, is the root, the power of the root, and then the numerator, b to the first, is remains the exponent of your b. So this is the square root, which we don't write a little 2 when we say square root, it's just assumed. The square root of b to the first. The second one then, the denominator is 3, so this would be the third root of b squared. And then finally this one would be the fourth root of b to the third. So we'll work with those definitions today, and then we will also work on reducing the radicals, which we've seen before in previous chapters. So here's our first example. We're just simplifying 27 to the 1/3 power. So that's going to be the third root of 27 to the first. If you remember back to simplifying radicals, we think about the prime factorization of 27. 27 will be 9 times 3, and then 9 is 3 times 3. So that's the third root of 3 to the third. Well, the third power and the third root are inverses of each other, so we're just left with 3 to the first. You could also think of it, if you kind of go backwards to this definition, you can think of this as 3 to the third, what's underneath the radical, but then that third root is the same as saying the 1/3 power. So raising a power to a power is the same as multiplying, so 3 times the third just becomes 3 to the first. So you can think of that either way. The second example got cut off for some reason. Let me just rewrite it. We're going to do 16 to the 3/4. So the first thing I'm going to do is rewrite this as a radical. So this is the fourth root of 16 to the third. And then I'm going to break 16 down into its prime factorization. So that's 4 times 4, or 2 to the 4th. If we break that all the way down. Sorry, that got sloppy. So we have the fourth root of 16 is the same as 2 to the 4th. So underneath that radical there, you can really just think of this as the fourth root of 2 to the 12th. And when we're talking about taking the fourth root of something, groups of 4 can come out of the radical. So we have 3 groups of 4 because we have 2 to the 4th happening 3 times. So that leaves us with 2 cubed, which is 8. Again, another way you can think of it, if you like it more, is rewrite it as a rational exponent. This would be the same as 12/4. Well, 12 divided by 4 will just get you back to that power of 3. So either way you want to think about it works. Alright, example 3. My directions got a little cut off in this one as well. The directions are to write it, the expression here, in exponential form. Meaning writing it with rational exponents. Right now it's in radical form because there's a radical. We're trying to write it in exponential form with an exponent. So the first thing I'm going to do is break these up. We have both the third root of p to the 4 and the third root of q. Remember, multiplication, we can think about multiplying those separately. So then I can just write the exponents of each of these. So if it is the third root, then the denominator of my rational exponent will be 3. And then the numerator would just be the power of whatever is inside. So this is p to the 4, so the numerator is 4. Here we have q to the 1, so that'll just be q to the 1. And then the denominator is also root 3, so 1/3. And there it is. The same expression that was written in radical form is now written in exponential form. Alright, for examples 4 and 5 here, we're going to be writing the answers in simplest radical form. So this first one is already given to us in radical form, but we just want to simplify. So a couple ways you can think of this here. The first thing that I want you to know is this is the 8th root, so this is the square root of 8, and this is the 6th root of 8. These are not the same radicals. You cannot just multiply 8 and 8 together. Because really, if we think about it in exponential form, we have 8 to the 1/2 here times 8 to the 1/6. This is an easy way to look at it because you know what to do with exponents when you have like bases that are being multiplied together. You add them. This is the same as x to the 1/2 plus 1/6. So if I add 1/2 and 1/6, I get 8 to the 4/6, which if I reduce that is 8 to the 2/3. But we do want to have our answer in simplest radical form. So I'm going to rewrite this as a radical. The denominator makes our root, so it's the 3rd root of 8 squared. And then now we just need to simplify. So the 3rd root of 8 squared, don't forget if you break down 8 into its prime factorization, that's 2 cubed. So I really have 2 to the 6th there, and that becomes the 3rd root of 2 to the 6th, which is just 2 squared, or 4. Really, if you want to do some of that from straight here, I'm trying to kind of show you guys how to look at it both ways, because the whole idea is, can you interchange between radical form and exponential form? If here you just want to rewrite 8 as 2 cubed, so 2 cubed to the 2/3, raising a power to a power, you just multiply exponents, so these 3's would cancel, and then you're still just left with 2 squared, or 4. So whatever way you like to look at the simplification, it's up to you. The point is that you can move back and forth between writing them in either way. Alright, example 5. Same idea. Write our answer in simplest radical form. But what I'm first going to do is write it in exponential form, because it just makes it a little easier to look at in the beginning here. So we have 8 to the 3/5 divided by 4 to the 2/6. Before I even do work here, I'm going to go ahead and simplify these like I did in blue above. I'm going to rewrite 8 as 2 cubed. And I'm going to rewrite 4 as 2 squared, just breaking it down to those prime factors. And then I'm going to simplify. Raising a power to a power, we multiply. So 3 times 3/5 is 9/5. So this is 2 to the 9/5 divided by 2 to the 4/6, which does reduce. But what we can see here is now we're dividing like bases. When you're dividing like bases, you subtract the exponent. So it's 2 to the 9/5 minus 4/6, which is 2 to the 17/15. So if you get your common denominators there and do your subtraction. So at this point, I think I'm going to rewrite this as my radical, because our answer is going to be in simplest radical form. And it's the 15th root of 2 to the 17. Now, when we have a 15th root, any set of the power of 15 can come out of the radical. So what I have underneath the radical there is 2 to the 15th, but then 2 more left over. So the 15th root of 2 to the 15th is just 2. And then we're left with that 15th root of 2 squared, which is 4. And there's our final answer for that one. Alright, the directions for this one are to simplify each expression and give our answers in exponential form. Alright, so for this first one, I might go ahead and just rewrite the division sign with a division bar. It's just a little bit easier to look at, because what we're really doing is dividing this first term by x to the 1/2 and the second term by x to the 1/2. So I'm even going to rewrite it and split them up. Okay, so just like we did with the previous example, when you're dividing like bases, you subtract the exponents. So this first term here is just x to the 3/2 minus 1/2. which we know is x to the 2/2, or just x. And then here, we're going to also subtract our exponents. So bring down our 2, but then we have x to the 5/2 minus 1/2, which is x to the 4/2, or x squared. X and x squared are not like terms, can't combine them, so that's it. That's our answer in simplest form and in an exponential form. Alright, so the directions for 7 and 8 are just going to be to solve. So here's the thing with rational exponents. The way to get rid of rational exponents is to raise both sides of the equation by its reciprocal. So what do I mean by that? Here I have y to the negative 1/2 power, but I'm trying to solve for y. I want just y, not y to the negative 1/2. Well, the way we can get this exponent to just be 1, which is what we want, is to multiply it by -2. The way to multiply it by -2 is to raise it to the -2nd power, because we know when you raise an exponent to an exponent, you multiply their powers. But this is an equation, so we have to keep it balanced, so whatever we do to one side, we do to the other. So we've raised both sides to the -2 power. That gives us y on the left-hand side as intended, and then 6 to the -2 on the right-hand side, which we just need to simplify. Remember, negative exponents are the same as bringing it to the bottom, making it positive, so y is 1/36. Let's try another. If I want to get rid of -2/3 power, so I can solve for that x there, I'm going to raise it to the reciprocal. I'm going to raise it to the -3/2 power. Again, whatever you do to one side, you have to do to the other. So, note here that 9 is inside parentheses, so we're just going to be left with 9x. So those are raising powers to a power, so they multiply to +1. And then on the right-hand side here, we have 4 to the -3/2 power. So a couple things we want to do here. We want to get x by itself, and we also want to simplify that -3/2 power. So let's work with that right-hand side first. What I might do is rewrite that as a radical, because this is the square root, since there's 2 in the denominator, of 4 to the -3. But 4 to the -3, we can bring that to the bottom and make it positive. So we have 9x equals the square root of 1 over the square root of 4 cubed, which is 64, or just 1/8. So kind of a lot of work with simplifying this one. But last thing we're going to do is divide by 9 on both sides, and we're left with x equals 1/72. Again, the key step there is you understand when you solve an equation with rational exponents, you must raise each side to the reciprocal of that exponent. Alright, that's the first lesson of chapter 10, so it's 10.1. Go ahead and check Schoology for homework.